In this work, we introduce a system that supports visual text mining with progressive taxonomy construction for environmental studies. In environmental science, the DPSIR framework is proposed to study and communicate the complex relationships between societal and environmental factors. In practice, scientists will collect, organize, and analyze sources of documents to contextualize the DPSIR framework, which is laborious and inefficient. Moreover, there are some unique challenges in automation support. First, the DPSIR taxonomy is dependent on the research questions and studied region, which makes it hard to design a universal taxonomy. Second, scientists usually progressively update the variables as they gain deeper understanding about the ecosystem, which makes evaluation challenging. To address these challenges, we work with environmental experts and design a system that supports interactive text mining based on prompt engineering. For the first challenge, we design a three-step prompting pipeline that allows the experts to adjust the taxonomy to fit the context. For the second challenge, our system supports evaluation and exploration with an uncertainty chart, which plots uncertainty and the semantic similarity on the same plot. Users can use this chart for evaluation and get actionable insights on how to refine the taxonomy definitions. Next, let's see how the system works with a case study. Our collaborating expert, Jason, is studying public opinion on the environmental policies for Liudao in Taiwan. He has collected a corpus of interview transcripts and wishes to refine an existing DPSIR taxonomy derived from the literature. He imports the corpus and the initial taxonomy into the system. He can execute each of the steps using the initial taxonomy and refine the taxonomy definitions. In addition to a simple list view, he can use the uncertainty chart to inspect the uncertainties and topics at a glance. He can also use the side panel to compare the results side by side. For example, during indicator identification, he finds an outlier snippet in the drivers that has high uncertainty. He inspects the snippet and finds that the interviewee is talking about a historical event that causes the residents to value culture security. He believes that this is something that is often overlooked in the literature and adds cultural security to the driver taxonomy. The system also provides several auxiliary visualizations. For example, he can use the keyword cloud to inspect miscellaneous keywords, or use the link graph to inspect complex variable relationships in a snippet. He can also quickly navigate to relevant conversations in the document panel. After several iterations, Jason is satisfied with the taxonomy and the insights he gained from the system. To provide an overview of the mining results, the DPSR graph aggregates all the variables and links into a graph and supports progressive disclosure. Jason can use it to communicate the insights he gained, such as the most significant variables or some unexpected relationships. The design follows existing diagrams in environmental studies, which is ideal for collaborative discussions among environmental experts. We evaluate the system with an expert review and find several promising potentials of the system, such as informing policymaking, facilitating public-facing presentation, and comparing detailed research questions. We also discuss broader implications for other text mining application scenarios. For example, similar challenges exist in thematic analysis, and our approach can inform researchers in supporting LLM-facilitated thematic analysis. Our solution for supporting human-in-the-loop evaluation based on uncertainty can also be applied to other knowledge-intensive tasks. We discuss these lessons learned and future opportunities in the paper.